Welcome to Suchitra's statistics classes. Today we are going to discuss about standard normal distribution. A normal distribution with a mean mu equal to 0 and standard deviation sigma is equal to 1 is called a standard normal distribution. That is, when x follows standard normal distribution, PDF of x, f of x is equal to 1 by root of 2 pi e raised to minus x square by 2 minus infinity less than x less than infinity. That is, the range of x is in between minus infinity and plus infinity. It is denoted as x follows n0, 1. Now let us think about the properties. Symmetric about 0. That is this is the graph of a standard normal distribution. It is symmetric at x equal to 0. Mean, median and mode is equal to 0, coincide at 0. Quartile deviation is 2 by 3. Mean deviation is 4 by 5 approximately. That is root of 2 by pi. Beta 1 0, beta 2 3. And moment generating function is e raised to t square by 2. These are the important properties of a standard normal distribution. By putting mu equal to 0 and sigma equal to 1 in the probability density function of a normal distribution, we are getting the probability density function of a standard normal distribution. And this can achieved by the transformation z equal to x minus mu by sigma is called z transformation. So using the z transformation, we can change normal distribution into a standard normal distribution. And the graph of a normal distribution is this one, and graph of a standard normal distribution is this one. What's the difference here? Instead of mu, we have 0. This curve is symmetric at x equal to mu. Here the curve is symmetric at x equal to 0. And mu minus sigma is minus 1. Mu plus sigma is plus 1. And so on, we can compare normal distribution and standard normal distribution. That is derivation of PDF of n01 from n mu sigma. When x follows n mu sigma, f of x is equal to 1 by sigma root of 2 pi e raised minus x minus mu whole square divided by 2 sigma square minus infinity less than or equal x less than or equal plus infinity minus infinity less than or equal mu less than or equal plus infinity sigma greater than 0. Let us put z equal to x minus mu by sigma by changing the rule of variable. We can write f of z equal to f of x into mod dx by dz, or more elaborately we can write f of x in terms of z into mod dx by dz. How to rewrite x in terms of z? We know that z equal to x minus mu by sigma. So sigma z is x minus mu. So what is x? X is mu plus sigma z. And dx is sigma dz. So dx by dz is sigma. And we know that sigma is positive. So mod dx by dz is equal to sigma. Let us substitute these things here, which is equal to 1 by sigma root of 2 pi f of z equal to 1 by sigma root of 2 pi e raised minus x minus mu whole square by 2 sigma square becomes z minus z square by 2 minus z square by 2 x in terms of z into mod dx by dz, that is sigma. Sigma and sigma get cancelled, so we have 1 by root of 2 pi e raised to minus z square by 2. And what is the range of z? Range of z is from minus infinity to plus infinity. So this is the PDF of a standard normal distribution. This Z transformation is called standardization. That is shifting the origin to 0. That is from mu to 0 and rescaling with a standard deviation 1. That is, we know this is Z equal to x minus mu by sigma is shifting the origin from mu and rescaling this random variable with a sigma. So we are getting our origin as 0 and standard deviation as 1. That's why this distribution is called standard normal distribution. Now let us think about the importance of a standard normal distribution. We know that for the different values of mu and sigma, we have different curve. But for a standard normal distribution, we have a unique bell-shaped curve like this with mean 0 and standard deviation 1. So, for the comparison purpose, we are using standard normal distribution instead of normal distribution after the proper transformation, after the proper Z transformation. That is the importance of a standard normal distribution. That is for comparison purpose. So let us read this text. The different distributions that are normal will have different means and different standard deviations, which are the parameters of the distribution. But in standard normal distribution, mean is equal to 0 and variance is 1, that is unique. And we have a unique table called standard normal table or Z table. And we know we are using distribution for comparison purpose. So, for comparison of probabilities and events, we widely use standard normal distribution instead of normal distribution with the proper transformation. And bicentered limit theorem, CLT, asserts that the sum of large number of random variables after standardization have approximately the standard normal distribution. That will again assure the importance of standard normal distribution. So we already stated we have a standard normal table, and let us think about what is meant by standard normal table. Body of the standard normal table gives the area between 0 and a positive value of z. That is, P of 0 less than or equal to z less than or equal to z alpha is equal to alpha, where this shaded region is alpha and this is z alpha. And this z alphas or z values are obtained from this row heading and column heading. If z alpha or z is equal to 2.35, how we can find the probability of z between 0 and 2.35? So, in this row heading, search for 2.3. This is 2.3. And we have a 5 here. From the column heading, search for 0.05. Then this is for 0.5. So the probability is 0.4906. Okay, and we know that the maximum value of Z, positive value of Z is 3.49. It is 3.49 and its probability is 0.4998. That is 50%, nearly 0.5 or almost the 50% coverage we have as a shaded region. So we are using this standard normal table for comparison purpose of problems from normal distribution after proper standardizing using its mean and standard deviation. Let P of 0 less than Z alpha is 0.3508. That is, this alpha is 0.3508. And we want to find the Z alpha, that is Z ordinate, using standard normal table. How we can do that? Search for 0.3508 in this standard normal table. By searching, we are reaching here 0.3508. After reaching the value in the body of the table, move towards the row heading, that is 1.0, and move towards the column heading, that is 0.04. So row heading 1.0 plus column heading 0.04, adding together we will get 1.04. Therefore, required result alpha is 1.04. That is, P of 0 less than Z less than 1.04 is 0.3508. We know that from the standard normal tables, we can directly obtain the shaded portion alpha or its ordinate Z alpha. Suppose we want to find P of minus Z alpha less than or equal to Z less than or equal to 0. And by the symmetry property, we know that this is equal to P of 0 less than or equal to Z less than or equal to plus Z alpha. And this will change to this situation, which we can obtain from standard normal table directly. Suppose we want to find this shaded region, that is the region between minus Z1 and minus Z2. That is P of minus Z1 less than or equal to Z less than or equal to minus Z2. This region is the difference between the region from 0 to minus Z1 and 0 to minus Z2. That is P of minus Z1 less than or equal to Z less than or equal to 0 minus P of minus Z2 less than or equal to Z less than or equal to 0. And by the symmetric property, we can rewrite this as P of 0 less than or equal to Z less than or equal to Z1. And this one becomes minus P of 0 less than or equal to Z less than or equal to Z2, which we can obtain directly from the standard normal tables. If our problem is of finding probability of minus z1 less than or equal to z less than or equal to plus z1. The required probability is this shaded region. And from the symmetry property, we know that probability from minus z1 to 0 is same as probability from 0 to z1. Therefore, we can rewrite this as P of minus z1 less than or equal to z less than or equal to 0 plus P of 0 less than or equal to z less than or equal to plus z1. This is again same as P of 0 less than or equal to z less than or equal to z1 by symmetry property plus P of 0 less than or equal to z less than or equal to z1. That is twice P of 0 less than z less than or equal to z1. So if you want to find probability from minus z1 to plus z1, that will change to twice probability from 0 to z1, which we can find directly from standard normal tables. Now we want to find the probability from z1 less than or equal to z less than or equal to z2. This shaded region is the difference between the region from 0 to z2 and 0 to z1. So we can rewrite this as P of 0 less than or equal to z less than or equal to z2 minus P of 0 less than or equal to z less than or equal to z1, which we can calculate directly from standard normal tables. These are the some basic procedures for dealing with standard normal tables. Thank you. Thank you for watching.